Distance of a line segment in Pythagorean theorem. Okay. What we're going to start with is our distance formula. So this is the distance formula, and I'll probably want you to measure it. D means the distance of a line segment is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. It's a pretty big formula to remember. Okay, this is fine. It can be done. And we're going to use it to find the distance of this specific line segment. Looking at it, we can't quite, well, actually it looks out really nice. I should have given it a different slope. But it's tough to tell right off the bat what this distance is. So we're going to find the distance. And in order to do that, we need the coordinates. So this coordinate here is actually -5, okay, and +7. And this coordinate here is 4 and -2. So here are our 2 points. So I'm going to write them up here so we can relate them. -5 and 7 and 4 and 2. Is that correct? Let me double check. Yeah. Oh, -2. Good. Because our distance formula deals with an x1 and an x2, a y1 and y2, that's the idea of giving them calling this guy number 1 and this coordinate 2. And it doesn't matter which you call which. You could make it vice versa. This would be x1, that would be y1. This would be x2, that would be y2. Does that make sense? Mm-hmm. Okay. So we plug these into our distance formula. I'll quickly do it on the right here. So I'm going to have to compress it just a little. But d will be equal to the square root of, and I guess I'm doing square root in red here, the square root of x2. Okay, so we'll kind of highlight this so we can easily see. Here's our x2. This is my x2. Okay, so that's the number 4. Subtract x1. Okay, I guess I'll do that there. x1. Which is -5. So we're subtracting -5. So I'm going to put in a little bracket here. And then we're going to square that value. Because when we subtract a negative, it's kind of like adding. Okay. Plus y2. I'll do him in blue, I guess. Which is -2. Okay. Minus y1. The only color left is that. Ooh. Okay. Which is 7. Okay, so -7. Did that all make sense? I plugged it in? Good. So our distance will be equal to the square root. And I'm going to change square root back to black. There we go. We'll add what's inside those brackets. So -4 minus -5 is actually like 4 plus 5, which is 9. Okay, so 9 squared. And this 9 is going to be really important. So we're going to I'll go back and highlight it after. Okay, and I guess we'll put that in brackets. Plus -2 minus 7 happens to be -9. Okay. Squared. The distance will be equal to the square root of, well, 9 squared is 81, plus -9 squared is still +81. Okay with that? Mm-hmm. All right. The distance is equal to the square root. We're going to add those two together. It actually equals 162. So we have to find the square root of 162. Trying out my new calculator again. Let's see if it works. Oh, yes, it does. 162. Square root of that is 12.7, we would say. Okay, so it's 12.7 approximately. And they didn't give us any units, so we would just kind of say units because it's on a graph. So 12.7 units is the distance here. Great. There's a formula with a lot of little ways to kind of make mistakes. But at this point, we've learned something else. Do you recall Pythagorean's theorem? Yeah. Okay. The reason I say we can use Pythagorean's theorem is because distance formula is Pythagorean's theorem, just written differently. The only thing is I have to make a triangle out of this, which I can do really easily. I can just draw a line down to where the other point lines up, and then draw a line across, and I've now built a triangle. Okay, so because I've built this little right angle triangle, I can use Pythagorean's theorem to solve this, because this is the hypotenuse now. I've created it so it is the hypotenuse of this little triangle. And we usually call the hypotenuse the C value, and we call the other ones the A and the B, and it doesn't matter which is A or which is B. So our formula normally reads C squared is equal to A squared plus B squared, okay? And I'll show you how they rearrange it very quickly at the end, but let's just kind of do this. The great thing about this is because it's already on a graph, I can literally just count my way down, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So my A value is 9. And if you recall, okay, actually that's the Y. We went down 9. Okay, so because I went down 9, It's kind of like thinking -9, you could say. And it doesn't really matter because whenever you square a value, it's going to make the end result positive. So I could have written it as 9 or -9. And in a triangle, we would probably call it positive because you don't have a negative side of anything. But the idea is we went down, and that's why it looks like negative. But I'm going to do it the way we would normally do a triangle. And I'm going to say the distance of that is 9. So my, and I guess for argument's sake, to make it a little clearer, I'm actually going to call that side B, just so it kind of lines up a little better. Okay, so we'll say this is B and this is A. So my B is 9. Okay, and when we count across, well, we get 1, 2, 3, 4, 5, 6, 7, 8, 9 again. We went to the right, so it's kind of like a positive. So my A value is 9, positive 9. Right? And it is the distance of a side, so that's 9. So that's 9 also. We've replaced A. So that's squared plus 9 squared is equal to C squared. So I want to show you already the similarity between this. Wrong pen. Here we go. Here's our 9 squared plus 9 squared, which is exactly this, 9 squared plus 9 squared. The only difference is this is over a square root. And why is that over a square root? What haven't I done yet here? Do you know? Because this is C squared, all they did was isolate. So D is really our C, because the distance of this is our hypotenuse. So if I brought squared to the other side, the opposite of that is technically the square root of 9 squared plus 9 squared. Usually, though, in Pythagorean Theorem, we don't do that till the end, right? And we already know from what we're doing, 9 squareds are 81s. Okay, I'm going to go back to C squared, just because that's how we normally do it. So let's say I brought it back again. 81 and 81 is 162 is equal to C squared. And we know to isolate C, we bring squared over, which gives us our square root. They just brought the square root at the beginning of the formula. And we already know our answer, the square root of 162, which is identical of above, is 12.7 units. So using Pythagorean's theorem, we can find that distance really easily without memorizing formula, because we probably already know Pythagoras. Okay? I'm going to quickly check something. Do you want to show you how Pythagoras turns into that, or does that kind of make sense as you go through it?
So you just have to draw
a triangle? Just make it a triangle.
Okay.
And as long as you draw it straight across, because it's right angle, you can only use Pythagorean's theorem with a right angle triangle. Yeah. You can use Pythagorean's theorem to find the distance of any line. It's very simple to do. The only ones that would be difficult, okay, and I'll show you them quickly, but they'll actually be really easy, is if I made this line or I made this line. Okay, and the reason being is because this I don't really make into a triangle, right? I could do this to find that, right? But then I'm no longer finding C. I'm finding like side A or B. Okay, and same with that. I could do this and turn that into a triangle. But I don't really need to, because if it asks me a distance, well, this is 9 and this is 3. I just count down, blah, 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 blah. That's 6. I don't even really need to go into it, right? And same idea here. This is at -6. This is -2. The distance between that would be 4. Okay? Those are the only ones that would look difficult. But anything with a sloped line, right angle triangle, Pythagorean theorem works the exact same way.